Chapter 1. Preface about MR Safety. In this video, you will learn more about the MR systems, the types of magnets, and the magnetic field. In addition, we'll provide an overview of different types of device labels for ferrous objects. Let's have a look at the core of a MR system, the magnet. There are several types of magnets used in clinical imaging. Permanent magnets always have a magnetic field. The permanent magnet can't be switched off, even in the case of an emergency. Superconducting magnets are the most commonly used magnets in clinical MR imaging and are used to generate higher magnetic field strengths. In case of an emergency, superconductive electromagnets can be switched off at any time. The patient is positioned in a powerful, homogeneous, static magnetic field generated by a cylindrical magnet. The static main magnetic field of a 3 Tesla magnet is approximately 60,000 times stronger than the Earth's magnetic field. The static magnetic field is generated by a superconductive magnet. In order to minimize hazards, the controlled access area of the basic field is identified and marked on the floor and is referred to as the 5 Gauss line. When people are exposed to the static magnetic field, possible effects can be dizziness, lightheadedness, or a metallic taste in their mouth, especially with magnetic fields of 3 Tesla and 7 Tesla. The static magnetic field used in MRI does not cause any lasting side effects. The same is true for alternating fields when used properly. Magnetic fields from MR systems can present danger. They exert an enormous attractive force on magnetic objects and objects containing magnetic materials. Once attracted by the magnetic force, these objects often cannot be held back and can accelerate towards the magnet and become dangerous projectiles. For 4 poles, stretchers, and oxygen bottles, make sure only MR safe or MR conditional tools and devices are used in the MR room. Don't carry any magnetizable objects on your person. For example, watches, pens, scissors, cell phones, credit cards, and ID cards with magnetic strips, etc. It is also recommended to keep the examination door closed. Always check to ensure you don't have any metallic objects on or in your body before entering the examination room. Certain implantable medical devices have been cleared, approved, and/or licenses by a competent government authority and/or labeled by the device manufacturer as MR conditional. It is the responsibility of the device manufacturer to declare an implantable medical device as MR conditional and to define the conditions, constraints for safe MR scanning. The MR operator must be aware of the conditions for MR scanning and refer to the labeling of the implantable medical device or contact the device manufacturer to ensure it is safe. Not all MR conditional devices are safe for all field strengths. The implant or device should also be verified that it is safe to be scanned at the specified field strength being used, 1.5 Tesla, 3 Tesla, or 7 Tesla. There are 3 different types of device labels for ferrous objects as related to an MR examination room. MR safe are objects which pose no known hazards in all MR environments. MR safe items include non-conducting, non-magnetic items such as a plastic petri dish. An item may be determined to be MR safe by providing a scientifically based rationale rather than test data. MR conditional objects have been demonstrated to pose no known hazard in an MR environment with specified conditions of use. Field conditions that define the specified MR environment include field strength, spatial gradients, time rate of change of the magnetic field, RF fields, and specific absorption rate, SAR. Additional conditions, including specific configurations of the item, may be required. MR unsafe objects or those which are known to pose hazards in all MR environments. MR unsafe items include magnetic items, such as a pair of ferromagnetic scissors. Attention! Only use equipment in the MR examination room which is labeled as MR safe or MR conditional. All non-labeled scanner items have to initially be treated as MR unsafe. The controlled access area encompassed by the 5 Gauss line for the field strength is established around the MR magnet and is clearly marked on the floor. In the case of a typical MR system, it is a few meters from the magnet center inside the RF cabin.